Welcome to Maths and Science by IITian channel. In this lecture, I will be talking about an inequality and under which conditions this inequality will be true, under which conditions this inequality fails. Some inequalities are called conditional inequalities. I want to explore about the conditional inequality and let us analyze an inequality which I have used in my previous lectures. Please see the previous lectures for this. This inequality is used in one of the lectures about finding a square plus b square when a cube plus b cube is equal to 7-digit number 9999991. That is a cube plus b cube, and to find out a square plus b square I have used this inequality. Now I thought it's prudent for me to explain this inequality to all for the benefit of all. Under what conditions this inequality can be used and why I have used in that particular problem. I want to clarify this so that you will understand inequalities can be applied conditionally and under certain conditions, and we have to visualize those conditions and apply the inequality and solve the problems. That particular technique and trick I will be analyzing and let you know, so that you will be benefited in solving the questions in the examination faster. The inequality is a square minus ab plus b square is greater than 1 by 3 into a plus b whole square. Under what conditions does it hold? Let us see. It's a conditional inequality. Question is, the given inequality is a square minus ab plus b square is greater than 1 by 3 a plus b whole square. Under what conditions? Conditions of applicability. And we'll cross check whether what we have applied previously was correct or not. Was it in the correct procedure or not? Solution. The inequality is a conditional inequality. Under certain conditions, this inequality can be applied. It is a conditional inequality. And what is that condition? A square minus ab plus b square is greater than 1 by 3 a plus b whole square. This is what is the inequality we have used, and this is what is the inequality we are going to analyze now. Now let us see what it means actually. Can we expand this equation? A square 3 into cross multiplication a square minus ab plus b square is greater than 1 into a plus b whole square. Let us further expand. 3a square minus 3ab plus 3b square is greater than a square plus 2ab plus b square. A plus b whole square is expanded and multiplied with 1. What it gives? Let's bring everything to the left hand side. What happens? 3a square minus a square minus 3ab minus 2ab plus 3b square minus b square is greater than 0. When you simplify, what it happens? 2a square minus 5ab plus 2b square is greater than 0. This is what is the inequality. It is in the form of a quadratic equation. This is in the form of a quadratic equation. What are the roots of it? Try to find out. If I say, for example, a by b is equal to some x. Let us assume, say, let a by b is equal to some x and b is not equal to 0. Then only a by b is defined. Then it is simplified as 2 into a by b whole square into b square, because 2a square I am writing as a by b whole square into b square, minus 5 into a by b into b square. Please, I am rewriting 5ab as this way. I am rewriting, that's all. Plus 2 into b square. That is greater than 0. And at the same time, what we have assumed? B is not equal to 0. Then what it happens? A by b is x. 2x square into b square minus 5b square into x plus 2b square is greater than 0. Do you agree? B square will take it as, because b is greater than 0, b is not equal to 0, which we have assumed, it says b square is greater than 0. Because it becomes b square into 2x square minus 5x plus 2 is greater than 0. Because b is not equal to 0, whether it is plus or minus, b square is always greater than 0. B square is always greater than 0. Then one is, for this to be 2x square minus 5x plus 2 to be greater than 0, it implies b square is greater than 0. That implies the above equation depends upon 2x square minus 5x plus 2. Now, let us solve 2x square minus 5x plus 2 is equal to 0, let us say. Then what are the roots of this equation? Roots of this equation, x is equal to minus b, that means minus of minus 5 plus or minus square root of b square minus 5 whole square minus 4 into 2 into 2 whole divided by 2 into 2. That is equal to 5 plus or minus square root of 25 minus 16 whole divided by 4. That implies x is equal to 5 plus or minus 25 minus 16 is square root of 9 divided by 4. that is equal to 5 plus or minus 3 divided by 4. That implies x is equal to 5 plus 3 by 4 or x is equal to 5 minus 3 by 4. That implies x is equal to 2 or x is equal to half. These are the roots of 2x square minus 5x plus 2 is equal to 0. If this particular equation to be more than 0, for this particular equation 2x square minus 5x plus 2 to be greater than 0 means x should be less than half or x should be greater than 2. For example, x is equal to 3. 3 into 3 is 9, 9 into 2, let us test, verify. 2 into 9, for x is equal to 3, let us verify. 2 into 9 minus 5 into 3 plus 2, that is 18 minus 15 plus 2, that is equal to 5, that is greater than 0. Either x should be greater than 2 or x should be less than 2. Let us say x is equal to 1 by 4. This is first test. Second test. 2 into 1 by 4 whole square minus 5 into 1 by 4 plus 2. That is equal to 2 into 1 by 16 minus 5 into 1 by 4 plus 2. That is 16 is the LCM. That is 2 minus 20 plus 32. 34 minus 20, 14 by 16. That is greater than 0. That means the conditions for 2x square minus 5x plus 2 is greater than 0 if x is less than half or x is greater than 2. Yet x is equal to half or x is equal to 2, this is equal to this becomes 0. Function x is equal to 0. Now, what is x? When x is equal to a by b, we have got this. Hence, the above equation or condition is positive greater than 0 if x is a by b. That means 2x square minus 5x plus 2. If you replace x by a by b, this equation has come from where? It has come from the inequality. Two x square minus 5x plus 2 x less than half and x greater than 2. That means a by b less than half and a by b greater than 2. Under these conditions, this particular 2x square minus 5x plus 2 is greater than 0. A by B less than half or A by B, it is not and it is R. A by B is greater than 2. That means either 2A is less than B or A is greater than 2B. That means either of the value is twice the other value, is greater than. That means either B is greater than 2A or A is greater than 2B, which says either value is greater than twice of the other value. That is the condition. For what? 2x square minus 5x plus 2 is greater than 0. From where it has come? It has come from the inequality. That is the direct derivative from the inequality, this inequality. That means that says a square minus ab plus b square is greater than 1 by 3 a plus b whole square is proved for values a is greater than 2b or b is greater than 2a. Both of them cannot be applicable at same time. Either a is greater than 2b or b is greater than 2a. That means when either of a and b, either of a and b are such that twice either of a and b are equal to, not equal to, greater than twice of other. That means if a is greater than 2b or b is greater than 2a, it implies that a square minus ab plus b square is greater than 1 by 3 a plus b whole square. This is the conditional inequality. Sometimes we may have to use the conditional inequalities in mathematics, algebraic, number theory problems. We cannot stick to only standard inequalities, we have to look at the conditional inequalities also. This is one of the conditional inequalities today we have proved, and I will apply to the previous example because some students have got doubts, not doubts, rather they have asked me about proving this theorem and also about applicability in that particular example. In that particular example, what we have got, a cube plus b cube is equal to 999, and we have got a square plus b square is equal to 66666, 1. and a plus b is equal to 1. If a plus b is equal to 1, either a should be 0 or b is equal to 1, or b should be 0 or a is equal to 1. When you apply these two, a cube plus b cube and a square plus b square values will not be satisfied. Then for these three equations to get satisfied, there should be some value of a and b separated by unity. That means a is equal to 1 minus b. Because b is always greater than 0 and also b is a big number. When b is a big number only, a will be a big number. You will be able to get 99999991 or a square plus b square 66666661. That shows a is negative if b is big positive. That shows 2b, that is a big positive value, will always be greater than a, or b is always greater than 2a. You see, when a is negative, b is positive, b is always greater than 2a. Whatever may be the value of b and a, when a is negative and b is positive, b is always greater than 2a. For example, let us say a plus b is equal to 1. That implies b is equal to 1 minus a. If b is equal to positive, because it should be a bigger number, showing a cube plus b cube is equal to 99999991, b is positive, then a is negative, or b is negative, a is equal to positive. In either case, the positive number is always greater than negative number. This is the rule of the fundamentals of arithmetic. Positive number is always greater than negative number when a and b not equal to 0. Then a and b not equal to 0. For non-trivial solutions, a positive number is always greater than the negative number. Hence, on either case, a is greater than 2b or b is greater than 2a, depending upon whether a is positive or b is negative, or a is negative or b is positive. If this is the case, a positive, b negative. This is the case, b positive, a negative. This is the logic, simple logic we have to apply. Then, under any circumstances, for the given problem, a cube plus b cube is equal to 99999991. Always obey that a plus a square minus ab plus b square is greater than a plus b whole cube 1 by 3. This is always obeyed, provided a is greater than 2b or b is greater than 2a, depending upon a is positive or b is positive. A is negative or B is negative. Both of them cannot be negative, both of them cannot be positive, because A plus B is equal to 1. One should be negative and one should be positive. Because since A plus B is equal to 1, for A cube plus B cube is equal to 99999991, both A and B cannot be positive together. Because A plus B is equal to unity and cannot be negative together. One should be positive and another should be negative. In this particular case. Hence, we have applied the rule A square minus AB plus B square is greater than 1 by 3 A plus B whole cube, because it is applicable in this particular case. With this, I want to close this lecture, and with this you might have appreciated there are conditional inequalities, true under certain conditions, and the inequality, the conditional inequality A square minus AB plus B square is greater than A plus B whole 1 by 3 into A plus B whole square. It is not whole cube, it is whole square, sorry. It is not whole cube, it is whole square. Valid when 2A is greater than B. What are the conditions we have got? Either A is greater than 2B or A is greater than B is greater than 2A. Two A is less than B, that means or A is greater than 2B. Either B is greater, because we can use A and B interchangeably. We can use interchangeably. Rather, instead of writing like this, what we can say? This will be holding good when the numbers twice of the other number. One number is greater than the twice of the other number. That way we can write. A is greater than 2B or B is greater than 2A. This is the condition. Rather than the negative number, the twice of the positive number is always greater than the negative number. Twice of the positive number greater than negative number. Don't worry about A and B. A and B can be interchanged because it is a symmetric equation. Whether you call it a square minus ab plus b square or b square minus ab ba plus a square, or either you call it as a plus b whole square or b plus a whole square, it's a symmetric equation, so that don't worry. Under these conditions, this particular equation is, particular inequality is valid. That means there are certain inequalities where we can put some conditions and say that that particular inequality is valid. If A is positive, 2A is greater than B. If B is negative, if B is positive, 2B is greater than A. Like this, as we have written here. B is greater than 2A, or A is greater than 2B. That you should be very, very clear on this. Either this one or this one. It's only interchanging A and B. It's not going to change the inequality, provided twice of the positive number is always greater than the negative number. This is the conditional inequality. If there is a value addition to your knowledge because of this lecture, please share my videos and my channel name, Maths and Science by IITian channel, to your friends, and subscribe to my channel. Best of luck to everybody. Subscribe to my channel. Best of luck to everybody. Thank you for seeing my lecture. Thank you. Always remember that an inequality can be a conditional inequality. That condition can be derived from the given inequality, and under those conditions the inequality is valid. Maybe under other certain conditions the inequality may not be true, but under certain conditions the inequality must be true. Please take care of that whenever you solve the problems in algebra. Best of luck. Thank you.